Guys, welcome to Learning Microcontrollers. In this lecture, as per my post, we will be starting a state-of-the-art cutting-edge STM32H753zi Nucleo-based board microcontroller. So this video is about a basic introduction, so let's get started. So guys, first let me tell you what you mean by Nucleo-STM32H753zi. Remember, number one, all STM32 144 pins microcontrollers have exactly same Nucleo board with same pinout. Whichever STM32 144 pin microcontroller you buy, and then you buy a Nucleo, like Nucleo, if it is written, then this will be exactly the same board. That is the beauty of STM32 electronics. Like they make the same boards with different microcontrollers. So like if you are using like F767, that's also 144 pin, exactly the same board. And if you feel the need, like you need some additional features or different features, then you may just plug that out and plug this in, and that will be all you need to do to change the features. So that is the beauty here. So guys, the next thing is, the one we use is STM32H753zi microcontroller based Nucleo 144 board. Now this is a very basic thing to understand before we move on. Here this board, the white part is the board called Nucleo. If you talk about 144 pin Nucleo board, then this will be exactly the same, this white part. See this area, except the center chip, this chip, leave this chip, rest of the board is the Nucleo board, while this chip, the center chip, is the STM32H753zi 144 pin microcontroller. Here the letter ZI means that it's a 144 pin. If this is different, then this means that it also have a 100 pin version, also have a 208 pin version, also have a 176 pin version. In that case, there will be no ZI. So if it is ZI, it means that it's a 144 pin microcontroller, and the board we are using is Nucleo. So this white part is the Nucleo board, the center chip is the STM32. So in short, again, the point number one, STM32H753zi microcontroller based Nucleo 144 board, or finally we say it Nucleo STM32H753zi, or whatever the microcontroller is, the Nucleo will be there, and that means it's 144 pin, whichever it might be, F767, F745, H745, or whatever the series you have. So this was some basic understanding of that name. Now guys, this over here is our Nucleo 144 pin package board. It looks like this. Whichever the Nucleo board microcontroller STM32 you have on the Nucleo board having 144 pins, you will always have the same board with same pinout. Now you can see that the board is well designed and it also shows exactly the pinout of your microcontrollers. You can see that. You can easily see the pins labeling as well. You can also see this on the top side as well, these connectors which come soldered. These connectors you have to solder yourself, whatever you prefer. So in my case, I have soldered male connectors. I show you my board, then we move on. So guys, there is the box, the board I bought, that is the STM32 board, Nucleo H753zi. See, so at the back you can see that it mentions the model here. See, on the box it says that S753zi83. ZI means it's a 144 pin package. So let me open and show you what is inside. So guys, this is the board. The board is exactly the same which I have shown you in the presentation. See that it mentions the same with a tag on it. Now these boards come in two shapes. One also have cuts over here, like you have cuts here. So if you don't want this part and you want to connect your ST-Link directly, you just break it from here. But this one do not have that. So I have no issue with that, neither I care. So now you can see that we have two ports. These blacks one, they come soldered, the bottom, the male ones, I have soldered these myself. So you can solder them yourself, whatever you prefer, the male or the female connectors, or if you have some others as well. So this is how this board looks like. Now you can see that this is a Nucleo board, as I have said. See the Nucleo H753zi. Now there might be F767, F745, F745, whatever the series you have, Cortex M7 144 pin microcontroller Nucleo board, the pinout of the board is exactly the same. Now that is the beauty over here. So let's go into further details. So first I tell you where I bought it, how much this cost. So if we say buy STM32 H753zi Nucleo board. I write it like this. Then there comes various vendors like DigiKey also have these. It's not very expensive. The features it have, it is a very computer board. Even AliExpress have this, and Moser also have this. Now let me show you. Now see, if I go to this DigiKey, on the DigiKey, the cost is around $28. This is the cost, $28 exact price. So that is not very expensive as per the features. Once you know the cost, then you will understand the feature. Now here is a very important feature, that it can be connected with an Arduino R3 shield. Now see, they are like even telling it themselves. Okay, let's go to the other side. Now on the Amazon, the same board, you can see the same board. It is around how much the cost? I think it's like 53 or something. I'm not logged in. So on the AliExpress, if you go there, but if I write STM32H753zi, press enter. Okay, there we got the board. So here too the cost is different, like we got 68. Okay, this is 48. Okay, that's fair. 48 with free shipping, that will not be a lot of money. So you can see that even you have the chips available. This is the chip only, and this is the microcontroller. I think the cost convention is something wrong. The rest is fine. Okay, you can see that they are easily available everywhere. Now if I go for the Moser electronics, okay, on the Moser you can see that the cost is 25 euro or something like that, 25 euro, 26 euro. It is also the same, the board is same. So this is easily available in the market. But remember that it might not be available in the local market, but the best option is to buy it from the AliExpress, because in the US there is a bit of things going on, like a more tariff or something. If you live in some other country, like I write here, some other country like India or Pakistan, okay, here we go, then the cost will be different for that country. I write STM32H753zi. Okay, see, it is like 13,000. It's like 25 or 26 US dollar. So that's way cheaper than expectations, because in the US there is a problem of tariff of something. I can understand that. Okay, here you go. See, it's 46, 47, and the shipping is free, so it is not a lot of cost. So in short, you can like take the DigiKey for reference. This is the best site I buy electronics from, the DigiKey. DigiKey have it at 28, so with the shipping it will be the same, 44 or $45. So this is not too much. Now let's get to the feature. So first of all, this is the page from where I tell you about STM32H753zi. As I told you in the presentation, the important thing is the microcontroller. Nucleo is just the board. So the microcontroller is based on the ARM Cortex M7. The best we have used till now was a Cortex M3 based Arduino Duo. Arduino Duo is a beast, and that is Cortex M3 or M4, while this one is the Cortex M7. Now it have 2 megabytes of flash memory, which is like way more than any I have ever used. The best I have used is the PIC 18, and that has around like 64 KB. So this is 2 megabytes. Like you can make a lot of huge projects with it. And the clock is 480 megahertz after multiplying the PLL. And exact clock I will tell you on the STM32Cube IDE. So 1 MB of RAM and rest is same. So let's get to the datasheet. You just click on download datasheet, then this will pop up. Now this is our datasheet over here. Now in the datasheet, some important things. Now see, he have left this crossed because it can be ZI. Because if it is ZI, then it will be a 144 pin package. This one over here. If it is something else like TBGA or something else, UBGA, it will have its abbreviation. That will be different pin out. The one we have is ZI, so it means a 144 pin package. Against Cortex M7, maximum clock is 470, 2 megabyte of flash, 1 megabyte of RAM. So it is more like a computer. Now here, if we take a look, again the same, that you have double precision FPU, L1 cache, etc. Now these things are not part of some basic intro, but I will tell you something which is important. So okay, that's perfectly fine. Okay, let's go down. I want to show you something else which is important, is that we go to the pin out, the ports and the pin configuration, which is important in every microcontroller. Now here you go, take a look here, the hardware. Now the important thing is that whichever microcontroller you buy from the market, you are basically interested in knowing the pin layout, that how many UART ports you have, how many SPI ports you have, how many timers, how many PWM you have, the important ports. Now first of all, if you take a look here, the STM32H7, now Z means it's a 144 pin package, Cortex M7, JPEG, it's JTech, that's not basic, so the basic comes here. Now there you have 32-bit timers, and you have two of the 32 bits timers. These timers are very rare, and in this microcontroller costing around $26, it's very cheap. Like you have 2 cross 32-bit timers, then you have 12 cross 16-bit timers. This means that you have total of 14 timers. And the great thing is that 14 timers means you can have a lot of PWM pins with high resolution. Like you can have a PWM port supporting up to 32-bit. So this will be a very powerful PWM generated using these timers. Then you have 6 SPI ports, which is again huge, 4 I2C ports, 3 I2S ports. Now 6 SPI ports means that you have 6 SPI ports. One SPI ports can connect a lot of modules at the same. So similarly is the I2C. I2C is designed to have master slaves, master slave, master slaves. So 4 means there can be a huge communication between you and any of the sensors or devices that supports the same. So the next important is the USART or UART. These are very important. The good thing is that we normally require UART in our projects, but USART can do exactly what the UART can do. So you can easily like convert this to this, and that's fine. So you have 8 of these, 4 USART, 4 UART. Then the next important thing is this CAN. The CAN bus nowadays is getting very common in the market. Many sensor modules and even complete systems run on CAN. And this do not only have a CAN, it have a fast CAN. FD means it's a faster version of CAN. It can like work at greater speed. It supports a conventional CAN, and it have 2 of these ports. Like you only have to connect logic level conversion IC like MCP2551 to make these TX and RX to CAN high and low, and boom you go. Then these ports, they are not very common, but they are used by something like SAI, SPDIF, HDMI, dual quad SP1, camera interface. You have a camera interface on board as well. This is also a very important thing. Then you have total of 144 GPIO pins. Like you can program them to do whatever you want. GPIO are total 114. Then you have ADC conversion, 16-bit of ADC module. The one I have used till now, the best one, are the 12 bits. That's in Arduino Duo. But 16-bit I have never used, and you have 3 of these having 36 channel. Like there are 3 modules of 16-bit ADC. Each module has 12 pins. This means that you have total of 36 pins for the 16-bit ADC. This is very powerful component, and many, or I will say 90% of the sensors you buy from the market work on the ADC protocol. Then you also have 12-bit DAC. DAC means one is the ADC, analog to digital, it is the inversion, like you are generating analog voltages from the microcontroller. So you have a 12-bit, which is a very powerful DAC having 2 channels, like you have 2 pins for the DAC as well. Now, these 16 channels they are not very common, and neither are very required here. So in the basic intro. So this was our basic intro to the pins and ports. Now the next things I would like to give you the overview is right over here. Now this is the same in some other way. Like you have ADC 2x2 STM32 ADC compatible. Like these pins are compatible with the libraries of STM2 ADC or ST library, whatever you use on the CAN. Now these are some like compatibilities which this microcontroller have is huge. It also supports GPIO pin is also supported with the headers of Arduino Uno version R3. So these are some compatibilities which this supports with the ARM and with nearly ST library, that is the ST library and STM32, both are easily supported with each other. So let's get back to the data sheet. Now on the data sheet, the next thing I would like to give you intro is, let's go down. Let me show you what I want to tell you. Okay, this is the architecture, and this is like not something very basic. So we will touch it somewhere later. Another thing is to first get to the, now take a look here. These are your oscillators. Like that's what I was trying to tell you, is that the clock you have is 80 megahertz maximum. That is after multiplying these PLLs, adding or multiplying these PLLs. By default, the crystal it says is around 4 to 40 megahertz, and then you use something, or you may use a 72 megahertz. I have seen on various boards, but it can be like minimum of 4 megahertz and maximum 48 megahertz. Then you multiply it with the PLLs, and then you make it 480 megahertz. So directly you do not install a 480 megahertz crystal. You basically use these crystals. Like you have a 32 kilohertz crystal to generate the clock. Then you have this crystal, and then you use the internal oscillator, and then you use the multiplications and PLLs. You add them, subtract them, and then you make whatever the frequency you want from these. Okay, let's go down. I want to show you another thing, the pin out. Okay, there you go. Okay, now what I've told you earlier is that this microcontroller has three forms: 100 pin, 144, 176, 208 or something. Now this one is we do not have, we have a ZI version. So for the ZI version, this version, this, if you have Z over here instead of cross, this means that you have this LQFP144 pin out. Now this microcontroller over here this is our pin out of our microcontroller. But on the board, if you take a look at this presentation, you will find out that the same pins and ports are over here, but they are like spread on the board. Like in case of Arduino, the 80 mega 320p 8p is here, and the pins are spread all over the microcontroller for easy interface. Now the same thing is happening here. So you have this board here, and then the pins are like expanded to easy interface on the development board. So this is the one we have here. Now the same pins lie here. So let's count the ports first. So we have 1, 2, E, port E, F. Then we have port C, port A. We also have port B, port F, port G, port E, port D, port G. Okay, the maximum we have is port G. It means that we have total of 7 ports, port A, B, C, D, E, F, G. Total 7 ports divided on 114 GPIO pins, and which also have further functions. Then we also have some oscillator pins and also VBAT, power pins, and VSS, VDD, these oscillators which are multiplied on the diagram to get the other stuff done. So let me open the STM32Cube IDE. So to give you, now this is like first time setting up this, like I bought this board for the first time and now I'm opening the Cube IDE. Then what happens? So let's open our Cube IDE. Let's launch the Cube IDE and let's see what the GUI of the Cube IDE has to offer. I will show you the beauty of this Cube IDE, how much easy it is for the basics to get started. So first of all, let me zoom in so you guys can see better. Okay, click on File, New. Okay, I think I accidentally clicked here. File, New. Okay, STM32 project. Here you click, then wait, it is launching. Wait. Okay, there you go. First of all, it asks for the board selector. You have to select the board. Now to select the board, there are various options available. Either you write the microcontroller name here, or if you know the board, like we know the board we have is the Nucleo-STM32 board, you write that board here. So you can write the board Nucleo, see, Nucleo-STM32. Okay, it shows Nucleo STH753zi, this one, H753zi, H753zi, this one. See, we just narrowed it. Click on it. This will automatically bring the board. Now this is the board. See, the ZI version is always 144 pin. So this is the one. It says like unit price is $27. That's fine. Now this is the board we have here. You can see that it again shows you some description, so you can verify that the board you have is exactly the same. So the great thing is it is Arduino, it's supported with the Arduino kit, like you can interface an Arduino easily. Click on next, write the name of the project, just a basic intro. I just want to show you the GUI, so to verify the datasheet, that how much the GUI follows the datasheet. Okay, click on finish. Now it is generating the GUI. Okay. Click on OK. Wait. Okay, it is rendering the GUI, turning on the GUI for us. Okay, now it will download some files because it is the first run. First time it always downloads the library. The GUI needs to be uploaded and downloaded. So I will pause the video so until the downloading is done. Okay, here we go. It's nearly done. So it may like download and install other component, but this is done only the first time. First time you start, then this is how it works. Okay, it's nearly done. 10657, and here you go. Now this is a huge microcontroller with huge features, so I can like continue to a huge time. Okay, just wait. This is a free software and free IDE, so you just have to, like, I have a lecture on this, how to download and install this. You just have to log in. That's all you need to do. You don't have to buy anything for the license. Now, as I told you, it will download more stuff as well. So let's wait. Okay, let it download. So guys, here the packages have been downloaded. Now take a look here in the GUI. This is the GUI of your STM32 microcontroller libraries. You can see that how nice it is. So let's verify what we found on the datasheet. Is it true or not? So there you can see that we have the same packages. Oh, okay, this looks bad. So let's zoom it from here. It will clear the things. Okay, this is better. Okay, now take a look here. Start from the P2, P3, P4, P5, 6. And now let's get to the datasheet. Now on the datasheet, we take a look here. Now see, it is exactly the same. PE2, PE3, E4, E5, E6, port E here. Then the 144 is VDD PDR on. We check. Now see, VDD PDR on. Then on the E1, it says that if it has connected an LED, the yellow LED is on the board. So these LEDs, if you go there on the diagram, or if you take a look at the board, you will see that these LEDs are also available on the board as well. So the Nucleo board already have the LEDs. You do not need to connect additional LEDs for testing, for writing a test code, which we will do in our next video, in blinking an LED video. So you have LEDs on board. These you can see LD1, LD2, LD3 over here. These one. So they are the LEDs. So they on the Cube IDE is shown with this. This is LD2. Now there will be the same, the LD1, another. So it says LD1 over here at pin number B0. Now see, this is exactly the same. What I wanted to show you over here is that this is the same which is here on the datasheet. So if you ever have any problem in using this microcontroller, then you will simply refer to this datasheet. The problem is that people do not understand that what the STM32 is and what the Nucleo is. Nucleo means it's just a board, and STM32H753zi or any microcontroller is a chip on this board. So you will refer to this datasheet. There is no datasheet for the Nucleo-STM32 giving you this information. So this will be only in the datasheet of the microcontroller. So you have all the pins here. Then the great thing over here in the GUI is that now see, the same pins are spread on the board. Like if you go check these out, these pin labelings, you will find out that they are exactly the same pins. These pins on the connectors, they are the same which are on the microcontroller, just spread out for our easy access. PC8, PC9, port A, B, C, D, then you have port G and others, etc. So now the next thing I would like to tell you is that we go to the GUI of the Cube IDE, and on the left side you have your analog pins. See, it shows ADC1, ADC2, ADC3. As per the datasheet, you have 3 ADC modules. Each is 16-bit, and each module has 12 channels. Like ADC1 has its 12 pins, 2 have its 12 pins, 3 has its 12 pins, and each pin supports a 16-bit. So see, this is the 1, 2, and 3 each having 16 pins. See, starting from input 0, input 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. So it is total of 12 each ADC module. So you have total 3 modules having till 11. So 36 total channels of the ADC pin. Then as there is a DAC, DAC 1, and then you also have the DAC 2. So you have 2 DACs, DAC 1 and 2. Then you also have the comparators and other stuff. So these are some analog features. Basics are only the ADC pins that have been discussed. Okay, then you have timers. As per the data sheet, we have discussed the timers. Then you have all the stuff that we have in the data sheet is verified over here. You have 4 I2C, 1, 2, 3, 4, 2 FT cans, see the same. Then you have the UART ports, UART 8, UART maximum. You have like 4 USART, 4 UART. Then additional, you also have LP UART as well. That can also be used, but this one. This is the LP UART. You can like say you have 9 UART ports, because this can also be configured. This is a low power UART. LP UART. So this can also be configured to do exactly the same with the UART is to do. Now rest are like not the basics, so you can like skip them for this basic. So guys, this is it. That is what I wanted to tell you about how you get to this microcontroller. The last thing is the clock. Okay, you can see the clock over here. Now what I told you is that the crystal you have on the board can be like 48 megahertz or 72 megahertz. The maximum I have seen is 72 megahertz. Here it says that you have a 64 megahertz on board crystal. Okay, there can be a 64 megahertz crystal on the board, which is just fine. And then it is using, now see there the multiplications are taking place. You can change the clock like you want. Like for every port, like for the UART port, it says it has set this clock, this mode. For the UART 2, 3, 4, 5, 7, 8, you can change these if you want. UASART 1 to 6, you have 64 megahertz. USART like directly getting from the crystal installed. LP UART 160 working at 64 megahertz crystal, 64 for the timers. For the 6 SPI you also have the same. 4 and 5 you also have the same. Now for the ADC it is 129 megahertz crystal. Now for the USB it is 384 megahertz crystal, or you can call it the frequency it has set after doing its required multiplications and stuff. See now the oscillators, if you check over here, like you have 132.766. Now this is the hardware. This is the oscillator connected to the hardware, and this is input frequency. It can be 4 to 50 megahertz input. Like you have a 8 megahertz crystal, then these are the two you have on board crystals. Then you also have internal oscillators as well, which you are using, and then a crystal of like whatever value you have installed on the board. So multiple ports for crystals, and then you use the multiplications and other stuff to generate frequency for your required ports. Like for the CAN bus I may have different frequency, for the UART port I may have different frequency. It's up to me whatever the modes I set, other stuff. So for the basic, you must remember this thing, that whatever the crystal you have here can be like value can be changed using the multiplication of the pre-scalars and stuff to generate the clock that is required. So this is it guys. I hope you guys learned something from this video. We will be making more videos on these microcontrollers, so stay tuned. We'll see you in the next lecture. Goodbye until then.